Coming up next, our last talk of the day. It's Daryll Strauss with Covert Regional Communications with Meshtastic.
Sorry about that. Hello, everyone. So I'm going to try, who am I first, right? Software engineer by trade. I've done a bunch of high performance computing and cloud computing and zero trust stuff for my professional life. I'm not a radio engineer, that's not my background, but this was a lot of fun to use Meshtastic and play with these LoRa radios. So first, let me talk about what I mean by covert regional communication. What I mean is this has to be secure, right? We got to be able to talk in an encrypted way so other people can't listen to us. Regional, meaning in a limited area. We need to make it difficult for you to locate where the transmissions come from. That's a nice feature. If you can't if somebody is looking to do geolocation on you, they can't tell where you are. And we like pseudonymous users, right? It'd be nice to be able to talk on this network without having somebody able to identify you, right, with specific names in the future. Okay, why does this matter? This is the motivational part. This is not normal, right? Okay, just flat out, right? A lot of odd stuff is going on in the world right now. That was the quick scroll. We're living in a panopticon, right? I mean, and does everybody know what that is, right? In a guardhouse, in a prison, the panopticon is the guard tower that can look over everything all at once, right? This is from the EFF's surveillance, Atlas of Surveillance. This is literally right now, here we are, there's Pasadena up there right under the N of panopticon. These are places that are running automatic license plate recognition systems. These are the sites, all those little orange dots are the sites that are running facial recognition systems in our police departments. These are the places that are running camera networks, right? Talking to third parties and commercial systems, right? We've got drone systems coming out of downtown LA, right? We've got body cams in the police forces around the industries, around all the cities. We've got cell site simulators, LA and Long Beach, right? Both have bought cell site simulators according to the EFF database, right? So there's a lot of, and a cell site simulator, if you're not familiar, your cell phone is always transmitting your location to the local towers. It identifies you with a unique ID. We can track where you are, all this stuff. So this is going on everywhere, right? So if you are using commercial networks, right, you're being watched. If you're driving your car, you're being watched, right? All this is happening. Okay. You will be monitored. We need to support our communities. There are a lot of communities. You are going to have your favorites. I don't really care which ones those are, right? This can be transgender folks. This can be pregnant people in some of the states that are not allowing that. This can be ICE raids, right? All these things, you got to be able to support your communities, right? And we need to do that for emergency response. What happens when there's a disaster in your area? How do you talk to your community, right? What happens when the infrastructure fails for some reason or another? How do you stay in touch with, how do you report activities that are going on in your community, right? And how do you coordinate group actions when you don't want to be under that kind of surveillance, right? This is why we need covert regional communications. And I'm going to say here, I'm not a tinfoil hat kind of guy, right? I'm generally an optimist, right? But optimism is what leads to achievement, right? You got to do something, you got to pay attention, right? And you got to plan. C3I, military term, command, control, communications, and intelligence, right? All of those things require communication, right? You got to have people in charge, you got to have resources and people that you're working with, right? You got to be able to talk to them. They need to be able to feed data back to you so you can make intelligent decisions and so you can do the rest of your planning, right? So all of this is designed. My point here of all of this is to sort of motivate why we need covert regional communication. Now, Signal is a great product, right? I'm not dissing this at all. It is secure. It is easy to use. Recommend it for all of you. It works great, right? It does voice calls. It does video calls. I love Signal, right? But it is connected to your phone number. It requires a cell phone, which means you need to be on a commercial network, right? Cell phones are relatively expensive, right? You're not going to deploy them in different places, right? So all of those are issues with Signal. I mean, it works great for a lot of different applications, but you need to understand what threats you are concerned about, and then decide on whether or not that's an appropriate technology. And that's why I talk about the rest of the panopticon, right? You got to think about all those things if you want to do, if you want to be secure in whatever problem you're trying to solve. I'm going to bring up the Communications Act of 1934. Right? This is what established the FCC. And it's interesting, there's a paper there WGBH did from one of the professors in Boston, but basically what it says is the president has the ability in a case of war to take over communication networks. This was designed so that the president could give a speech to the people, but the way it's written, it could include the internet and it could include taking them over entirely. We'll see if that makes the courts and what they decide with that, but it's an interesting question, right, according to the professor. So what happens if your internet goes away? Okay, so let's talk about Meshtastic, right? Phase 2 of this discussion, a little introduction to Meshtastic itself. Basically, really inexpensive. Now, I'm going to show you this in a second. A LoRa radio. LoRa is a long-range, low-power radio. You need a microcontroller of some sort, been built on S3 ESP32 microcontrollers, RP2040 microcontrollers, NRF microcontrollers, and some open source software, Meshtastic. It's not LoRaWAN. You may see references to LoRaWAN. That's the commercial protocol that LoRa pushes for stuff, but it's different, right? Meshtastic.org, that's where you're going to go find it. Meshtastic creates a mesh network. It's instant anonymous join, right? You plug in your node, you turn it on, you join the network. There's nothing else to do. Basically does texting. It's relatively low bandwidth. So think of it like a text message. The hardware is incredibly inexpensive. You can get a full-on node for about 20 bucks. If you want a mobile node, it's around $100, right? That has all the features, everything you need to be mobile. You can do solar and a battery and stuff. Again, it's around $100 by the time you put all those pieces together, right? So really inexpensive. It can be connected with MQTT. So if you need to extend over a wider region, you don't have nodes in between, you can use the internet to send stuff using that mechanism. And it has a full-on software API, right? So you can write code that talks to it as opposed to doing it through straight texting, right, through your keyboard. This is the devices page on meshtastic.org, and I'm going to stop a second and show you a couple of these. This is a LilyGo T-beam. This is kind of the size and shape of what we're talking about for all these things. This has an 18650 cell on the back of it, so it's battery operated. This little dangly bit is a GPS radio, is a GPS receiver. And it's got a little display, and it speaks Bluetooth, right? So you would connect to it with your phone, and you would talk to it that way, or any other Bluetooth device for that matter. But that's an example. This is designed primarily for hikers and stuff. You could put one up at your base camp and have a way to communicate, and your hiker could just carry this around with them, and it's constantly reporting position back from the GPS, as well as giving you a way to communicate with your base camp, right? This is a little more interesting for the application we're talking about. This is a LilyGo T-Deck, right? So this is a keyboard and a screen with an ESP32 and a battery built in, right? So now I have a full-on means of doing communication without having my cell phone with me, right? Around $100, right, for this device. This one is turned on right now. I'm getting messages through this. Somebody's streaming a bunch of odd stuff in the public channel, but that's okay. You can block nodes and other things, but we'll talk about that some more. But lots of different choices of hardware configurations that you can pick from with different sets of features. And almost all of these are straight up standard development boards, so you can connect other hardware to them. They have them connected to weather systems, for weather monitoring or other things. That was kind of the original LoRa, point from an industry perspective, was to do device control, right? Hardware, remote device control. So this is some of my hardware back at the house. That node, that's a 3D printed case and has a battery in it, and the cable coming out of the bottom is what connects to the solar panel, and that just sits up at my house all the time running. There's the hardware you're seeing now. The other antenna there is a roof mount, a magnetic one you can put on top of a car or whatever and drive around and do that kind of thing. And another little unit, that a little smaller display without the battery and stuff in the back. So if you've not done anything with Meshtastic, incredibly easy to do. As I said, get a node, connect it to your PC. There's a web flasher. There's the interface for the web flasher. It's about that easy. The left box is select your hardware from that big display list that I just showed you of all the different kinds of hardware. Pick which version of the firmware you want to apply on it, and it's using web USB to talk to the device and do the programming and everything else. So it's really easy to get started. You connect your node with Bluetooth, run Meshtastic on your phone, connect it with Bluetooth, select your region. There's different frequencies that they're going to run in different regions, so you got to tell it which region you're in. And there's some other options you can configure if you want to, but you don't really even need to. Once you configure your region, you're pretty much done. You could start using Meshtastic. So incredibly easy to play with. Did anybody go to the class that was on the other side on Intro to Meshtastic? A few people? Okay. So in the US, we're running on the 915 megahertz band. That is an unlicensed band for industrial, scientific, and medical devices, which basically means you don't need a license to do this, no registration with the government to use this technology. It's really low power. It's about 1 milliwatt powering, surprisingly effective, and I'll talk about that in a second. It used something called chirp spread spectrum. And again, remember, I am not a radio guy, but basically what that means is it's flipping between multiple frequencies and sending in small bursts, right, every time it wants to transmit, right? That on the right is a little spectrum display. So how far can these things go, right? In an urban environment, about 2 to 5 kilometers. A rural environment, they're saying 5 to 15 kilometers. The record's about a 1,300 kilometer transmission with directional antennas. Think of it as kind of line of sight-ish, right? I mean, you get a little bit, you don't need line of sight. It's in the building right here and it's working, but that's kind of a reasonable way to think about it. Because this is a mesh network and all the nodes are talking to each other and sharing, you can set multiple hops. You can send your data and tell it how many hops you want it to transmit for. And so you can get a much broader spread than just your own radio. So around here in LA, 5 hops gets about 50 kilometers for me, 25 miles between my house up to Burbank and down to Fullerton and kind of that range of stuff. I recently had a radio contact 77 kilometers away from me, right? And I sent something out and it's like, I heard you on radio. And I'm like, holy cow, you're that far out. But so sometimes you get even better, right? That was that roof node that I was talking about. So it's really active here in Southern California. That's a map of all the nodes that are in my node database on my LoRa node, right? There's about 300 nodes that I'm seeing being within a certain day or two or whatever it is that keeps them live between San Diego and Simi Valley. Lots of chatter going on the long fast channel. That's the default one that Meshtastic comes up on. I'll talk about the configurations in 1 second. But that's a public unencrypted channel for everybody to just chat. General chat room, right? You get what you get. SoCalMesh.org has a nice little organization. They're running some tools that do MQTT for you, and you can go to their Discord and you can see everything that was sent out on the channels, so you can see who received it and measure stuff. So they're a good group of folks that help out with all this stuff here in LA. All right. So we're going to talk about LoRa configuration a little bit. Again, I'm going to go through this relatively quickly because we have a limited amount of time. So you have a modem preset here. I'm on what's called long fast. And there's several other options. And basically what you're doing is trading off range versus speed versus reliability, right? Because they can encode the signal to be more reliable, but then you use up some of your bits, so it's going to go slower. You can transmit with different options there. Long fast is the most popular one because that's what it defaults to. There's a hop limit that controls how many times your stuff will be rebroadcast. That measures utilization on the network. 7 is the maximum, right? It's not, the protocol does not support more than 7, right? So it is always going to be regional. There you go. So that's the LoRa config side of this. again, this doesn't matter, this is all in the docs, but you have other choices that have different bit rates. You can get up to about 21 kilobits per second. The long fast channel is about 1 kilobit per second, and these are how the symbols are encoded and the amount of bandwidth it's using, and other things about the radio details that I am not an expert in. So you have a couple other choices here in how to configure things, and the role tells it how your device is supposed to talk to the rest of the world. And then there's a rebroadcast mode that says when your node gets traffic for other people, how is it supposed to rebroadcast it? So we have some options for how to configure those. When I was looking at this, they've added a new one for ATAC, which is kind of interesting. That's the Android tactical configured data. So that's a standard for basically having communications between a group of individuals and being able to pipe the data back into a geographical information system and keep track of multiple people that are working together on stuff. I have not played with that, but that's a really interesting new mode that they allow the device to run in. That's too small for you to read. But there are a bunch of different client modes that you can put, role modes that you can put the device into. Do you want it to send position data frequently or not, right? If you're just trying to track the location of a thing, you might just want position data from your GPS, but not the other communications that your node might do. You can put it in a hidden mode that says, I don't want you to send anything, I don't want you to rebroadcast anybody, I just want to be able to send my own stuff out, right? There's also some router and repeater modes that are useful if you know you have a node that is in a really good position in the network as a whole, and you understand the network topology, you can use the router and repeater modes to make your node more efficient. But you got to be really careful because you can make the network worse if you use those nodes. So don't do that. That's an advanced mode setting. But there are a bunch of those. Position packets are sent by default. If you're in the normal mode, they get sent to whatever's your default channel, right? If you're in the normal role. So you can fake your position. You can put it, say, don't use my GPS, or I don't even have a GPS, and you can put in whatever coordinates you want for it. But sometimes you may want to know GPS positions of your radios or the people in your group. Your first channel is your default channel. So again, remember that position stuff's going to go to the default channel, but if you, and again, as it comes out of the box, long fast is going to be the unencrypted default channel, because that's where everybody chats. But you can delete the long fast channel and put a secure channel as your first channel, and now your GPS positions are still going to your default channel, but it's encrypted because it's on a secure version. When you make a new channel, a QR code gets created, and you can share that QR code with other people that need to talk on your channel, and that gives them the encryption key for that channel, right? And allows you to separate that traffic out and have it all be encrypted. So, you know, that one is just the one I call the LayerOne channel, but I just made a channel. You can also send data to a specific node, right? So every node is addressable, and there's a public key with it. So you can basically say, I want to send stuff to my specific node at home. And again, all that traffic is encrypted. And again, same kind of mechanism. So that's my home node, with, you know, the private key blocked out on the on the document. So let's say we actually want to make this into a totally covert device at this point, right? We really do want to hide this from the rest of the world, but I still want to be able to talk with my group of people. So what I'm going to do is I'm going to put the role into client hidden, right? And what that means is this is only going to send traffic when I want to send out a message, right? When I type a message on the keyboard, it's the only thing it's going to send. It's not going to send positioning data. It's not going to send node information data. All these other packets that would be a standard part of the Meshtastic protocol, it's going to skip all those and only send the ones that I want it to. I'm going to choose my hop count to be appropriate for my use case, right? I don't want to set it to 7 if I know I'm going to talk in a relatively localized region. I'm going to set it to a smaller number. Client hidden doesn't do any rebroadcast, so we can basically don't have to worry about what the rebroadcast mode is, right? Because it won't be involved anyway. Position information, again, you can choose to turn that on or off in the config. Depends on your application, right? If your group needs to know where your people are, then leave position on, and if it doesn't, leave it off. Just make sure that it's being sent on your secure channel, not on the default open channel, right? Not on long fast. I might turn off heartbeat so there's no blinking if my modem's, if it's doing that. Probably on the long fast channel. Again, there's nice advantages that there's lots of other nodes transmitting on that channel, so you're sort of hiding in plain sight, right? Your traffic is mixed with everybody else's traffic out there. You don't stand out in any particular way. And again, consider a standalone device like the TDEC, right, so that you can basically do this without having to have any other devices on you. So my node is going to receive messages normally. Everything that comes through is going to show up. Anything that's going to show up on my channel will show up. It's only going to transmit when I want to send stuff. So I'm basically, even if somebody was monitoring traffic with directional antennas on the 915 megahertz band, right? I'm only visible at the times I'm transmitting. So it's relatively narrow points of time that it's doing that little chirp spread spectrum to send my messages out. I'm fairly hard to locate. It's a low power signal, right? It's going to be hidden in a bunch of other 915 megahertz open devices, right? Again, we can decide whether or not we want to send position. If the client falls into the wrong hand, the traffic can be decrypted, right? So you got to be careful about controlling access to your device. If I have that, again, this is not forward security. This is just an AES key, right? So if anybody is capturing the traffic, right, could be quantum decrypted, as our last presentation said, eventually. But again, if you can get the key, you can decrypt it, right? So you want to be careful about controlling your device. Let's say you're in a position where there isn't enough mesh, right? There's not enough nodes out there. Well, these things are dirt cheap, right? Again, 20 or 40 bucks, right? All in. An 18650 cell will last more than a day, right? It can be solar powered and disguised. There are people literally selling things that look like lights that have an antenna sticking out of the top of them. They look just like a standard light you might mount on the side of a building. Don't install the secure channel on this, because if this is a node you're going to go position out there in the world, it doesn't need to decrypt any traffic. It's going to forward all the packets anyway, right? Whether it can decrypt them or not, it doesn't need to. So it becomes a role client. Hop count, again, you're going to set to you want, and you're going to skip decoding, and you have the choice of saying retransmit known only if you want, which basically means you load the node database with all the nodes, all the IDs of the nodes that you want it to retransmit, and then your little node that you've placed out in the public will only transmit your group's traffic. Now the idea here, and I didn't say this at the beginning, right? I can go to the top of any parking garage, and I can put one of these nodes and stick it on the side, and no one's going to know anything, right? They're cheap enough. You can throw them out in the wild, and there are people doing this just to expand the network in general, right? But it is really easy to deploy one of these in advance. And if it looks like a box like the one you saw on my roof, right? If it just looks like a generic box, no one is going to question it existing, right? And it can run solar powered for as long as you want it to, and they can even be remotely administered. You can set a password on it and remotely administer the thing. So it is really easy to deploy a node out there if you need to extend the network to an area that isn't otherwise covered. Again, the node can be hidden in plain sight. If you say rebroadcast only known people, then if your rooftop node somewhere is captured, the node database is captured, right? Because it's on the device. Somebody can read that back out. So be a little careful about that if that's a concern for you. And again, don't put the channel key on the node, right? Because you don't want them to be able to decrypt the traffic that it doesn't need to decode. It never needs to decode. The forwarding node never needs to decode the traffic, so don't bother to put that on there. So again, you got to think about what your threat is, right? Operational security is hard, right? So you got to think about how did you get to the location? Are you worried about facial recognition? Are you worried about somebody seeing you with this random device texting wherever you are, right? There are lots of questions you have to ask. Is your adversary able to track cell phones, right? Can they radio locate? Could they put directional location antennas around the area if this is let's say you're gonna do something at an event somewhere, then it's possible with the right adversary that they could put directional antennas around the event, and then every time you transmit, they could pick up your stuff, right? So you gotta think about who your adversary is and what you're protecting against. Yeah, and be sure you authenticate your users, right? So there is encryption on the devices, but that's really just telling you that the device is secure. You know, that tells you you're talking to the device. It doesn't tell you who's on the other side of the keyboard, right? If somebody has walked off with my radio, right, they're reading everything I've got, right? If you really need to know who's on the other end, maybe you need some other communication. The package has arrived at midnight as your code phrase or whatever it is, right? You need to authenticate who the person is on the other end. Right now, these are some of the limitations in Meshtastic, right? The node ID is currently attached to the Bluetooth ID on the device, which means there's no way to rotate that to a different ID. But it is open source software, and there's actually a feature request to allow this in the future, right? So they may add that. Data transmission can be unreliable. You have no guarantee when you're sending stuff out with the radio that it got to where you wanted it to get to. So, you may need other ways of checking it. It will acknowledge that somebody received it, but you don't know that it got to where you wanted it to go. And the data rates are relatively small, right? Again, we talked about this. It's more like texting, right, SMS, than it is about high data rate. You're not going to send images in a video call through this. So there we go. Support your communities. Set up a communication network. Get your people on it. Do it now. It's, doesn't hurt. First, it's great to add more nodes to the Meshtastic world so everybody get benefits. But if you can do this, you can be a benefit to the rest of the world. It's inexpensive to play with, and and easy to do, right? So there we go. That's it. That's who I am. That's the talk. I rushed through this. Questions? Up front.
So I know what one of the difficult things about meshing is if you have too many nodes or there's too many paths that you can have a message going around in a circle, or you can have basically a bottleneck created by the nodes not being able to figure out how they want to pass traffic. Can you speak to how it does that, how it figures out the best path?
Sure. So the question was, if meshing often has problems if they're overloaded or duplicate packets or that kind of thing, and that is all true. And I can give you some answers. I haven't gone too deep into the software itself. So yes, we occasionally see duplicate messages from things that sort of echo and bounce around. It does have a hop count that limits how far this stuff can go, so that's one of the ways that it's limiting it. It is smart about figuring out, from what I understand, it looks at like the farthest one that your radio transmission got to and then uses those to rebroadcast so it's not flooding the area. It also turns off, when the network is busy, it turns off some of the other state stuff. So normally the nodes are sending, like, it's node information out there, data gets sent at a regular interval, so it turns off some of those housekeeping kinds of packets that would normally go out through Meshtastic when it sees that the network utilization has gone up. So there's a bunch of things going on, and again, this is an open source product and it changes, and the 2.6 version that just came out a little while ago has improved several of the features compared to 2.5, so there's still a lot of stuff changing right underneath. Yeah, you don't have to do much at all. It's all, it all works really well today, and they're making improvements, right? So you don't have to do anything special to do that. Okay, in the middle.
Why is it one hop? So it's supposedly recommended instead of a limitation on hops, especially if you're leaving devices out of the world that can be then intercepted and then used to try to track your with the packet, how many hops away you are.
So why would you ever want to set, if you're trying to hide from anybody, why would you ever want your hops more than one? And in fact, hops could be 0, right, if you know you're within radio distance of each other. But that's fundamentally the problem, right? If you are within radio distance of each other, that's great, you can set it to 0, right? If you're not within radio distance of each other, then maybe you do put a node on the top of a parking garage somewhere, and now you turn your hop count up to 1. As I said, choose a hop count that's appropriate for the problem you're trying to solve, right? But you're absolutely right, lowering it keeps the traffic from getting broader into the world, easier to hide in that model, right? Fewer people can see it. So you're absolutely correct. What else can I tell you? Up front again.
So are you able to see, like, geographically where your messages are going as far as hops?
Can you see geographically where your hops are going? So the answer is, there's a couple different answers to that question. So there is a trace route feature, right? So I can send a packet and I can say, I want to send it to this guy, and it will tell me which hops it went through to get there, right? If you're not familiar with trace route. There are also nodes on the public version of the mesh that will forward it to an MQTT server so it's centralized, and then in the SoCal Mesh guys, right, that I was pointing to earlier, run one of these, and then they relay it out to Discord. So you can go look at the Discord channel and then see which other nodes, which of the ones that are connected to the MQTT server saw your packet, right? And that gives you a way to kind of judge how far your stuff is getting, right? So there's a couple ways you can do that, not necessarily as covertly, but in terms of understanding where your range is and how far it goes. On the left. I'm actually wondering right now, because there's a bunch of random stuff showing up on Longfast that I'm seeing on this node sitting right here. I don't usually see that at my house, but I'm 25 miles or so from my house. You can silence nodes and block them if you want to, and take those guys out, right? And in fact, you can get a problem with a badly configured node, where it doesn't forward stuff out and can basically black hole your traffic, right? So, there are. Given that this is an open network and anybody can join, a bad actor can cause some problems, right? I don't know how you would do that other than the fact that it is going to get rebroadcast by other nodes. So if he black holes you, it might come around through another route, right? Yeah. The question was, is there any way to tell if somebody is black holing your traffic? All right, anything else? Then thank you.